Today we're going to learn how to graph standard form of quadratics. On the agenda, we'll look at standard form, state all the properties of the graph, as well as learn how to graph it on the calculator. Let's get ready. You're going to need your notes, pencil, and calculator. Standard form has the exponents in decreasing order. So we have 2, 1, and then x to the 0. What do we know about standard form? Well, this c value at the end, if it's a word problem, is going to be my starting point, which means it's where it crosses the y-axis. So it is my y-intercept. So in standard form, I can just look at it and I can see my y-intercept. Make sure you write it as a point, so it'd be parentheses 0, comma, c value. And how do we find the vertex? Well, it's not as easy as when it's in vertex form and we can just pull it out. It does require a little formula, and that looks like this. When we have x equals negative b over 2a, and b and a come from my standard form. So we're going to use that to solve for x, and then we'll plug it back into those x's and solve for y, and we'll have our vertex. The good news is a is the same as a in vertex form. A has the effect that it vertically stretches, compresses, and changes the step pattern. So let's take a look at this example. We have y equals x squared minus 4x minus 2. I can see the y-intercept. It's right there, so I'm going to write it as a point, 0, negative 2. I want to graph it, so I'm going to be down at negative 2. The vertex takes a little more work, so we're going to do x equals negative b over 2a. So x is a negative 4 over 2 times 1, and x ends up being 2. That's the x of my vertex. I have to plug it back in to get y. So y equals 2 squared minus 4 times 2 minus 2. So y is 4 minus 8 minus 2, and y is negative 6. So my vertex is the point 2, negative 6. And I end up being way down there. I can check it with my y-intercept by using my step pattern. So my vertex here is 2, negative 6. I know that that is a minimum because it's going to open up. My axis of symmetry comes from the x of my vertex, so it's going to be x equals 2. Let's use our step pattern. A is 1, so that means I'm going to go up 1, left 1, up 3, left 1, and that does coincide with my y-intercept, and then I'm going to do it on the other side. From there, I would go up 5, connect this for my parabola. I'm going to dot in my axis of symmetry, which is the equation x equals 2. I can see that I am, in fact, going to have x-intercepts, but we are going to wait until the next lesson to learn how to find those. Can we rewrite this in vertex form? Sure. So this is standard form. If you remember, my vertex is 2, negative 6. My a value is 1, so it's going to stay 1. So I'm going to use the idea of transformations to write this in vertex form. So I'm going to have y equals, a is 1, so I don't need to write that. X is 2, which means I'm going to do x minus 2. Remember to square it to make it a quadratic, and then minus 6. And now that is in vertex form. If I graphed both of those, I could graphically check. Let's try a new one, and we're going to do this on the calculator. First, we need to decide if it's going to be a maximum or a minimum, and I look at my a value, and it's positive, so this is going to be a minimum. We need to know that in order to enter that into the calculator. So first, take a minute and enter this into y equals. So you should have this, and way down here, that's your x button, so you want to make sure you're using that for x. This is your y, so you're under y equals, and then type in your equation, and you should get this graph. This is a regular Zoom 6 window. If your window has been adjusted for some reason, you can always come back to Zoom 6 to get the 10 by 10. So we already determined that this is going to be a minimum, so I want to go to second, trace. So the second button, and then the trace button, and then down to minimum in this case, or maximum if it was going to be a maximum. And then we need to do this left, right, enter. You might just think that you can click your way through it, but I really want you to think about what you're doing. And we are trying to Tell the computer that that's my calculator, that that's my vertex. So when you hit second trace, it's going to ask you for the left side. So this will be a little blinking cursor over there, and you want to put it on the left side first, and then hit enter. Don't forget enter. And then you can see it's asking for the right side. So I moved my cursor to the right side of my vertex. Right side, and hit enter. And then it's going to ask you, do you want to guess? So you can see it's got these arrows here. It's running a calculation. It's trying to find the average there so that it can actually calculate that vertex. And here's my answer. It tells me it's a minimum. It's at -1, and we have all those zeros, so that's close enough to -1 after the calculation. -3. So my vertex is -1, -3. It was quite a few calculator buttons to get there. It's going to be very helpful if you have decimals or fractions as your vertex. Sometimes it might be easier just to use x equals -b over 2a. In this case, I would have had -10 over 2 times 5, so I can find out that x is -1, plug it back in, and get my y value. So sometimes it might be quicker to do it with the formula versus all of the buttons on your calculator, especially if you can't see the vertex and then you have to start adjusting your window. The vertex was -. So let's go ahead and we'll finish this one off. So my 1, -3. And I'm going to graph this at the same time. So -1, -3. It does open up because my a value is positive. Because it opens up, this is going to be a minimum. My axis of symmetry comes from the x of my vertex, so x equals -1. And we're going to dot in that line as part of my graph. The step pattern, which would normally be 1, 3, 5, I'm going to multiply that by 5, so it becomes 5, 15, 25, and you can see that this is in fact vertically stretched by a factor of 5. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 1, which does check with my y-intercept, which is 0, 2. So I always like to move that step pattern and see if it really does hit my y-intercept and if I've got my correct step pattern and my correct vertex. X-intercepts, again, we're going to save those for next class so that we can solve those. Domain is all real numbers written within interval notation as -infinity to +infinity. The range comes from the y of my vertex and includes it, so it is hard bracket -3 to infinity. And my end behaviors are going to both approach positive infinity. So just to recap, standard form is in the form of ax squared plus bx plus c. 0c is the y-intercept. We will be using this to solve for x-intercepts in our next class. You will need to find the vertex using the little formula x equals -b over 2a. Plug it back in to find your y value. Good job.